Alright, welcome to video 4 for Mecanum Engine Part 2. Alright, so I'm going to be going over the individual projects. So as you can see, I have this massive terrain here. So as I explained in the initial demo video, what I'm doing here is just taking a height map and doing some calculations on it, some randomization functions. And then taking the Y position value and applying a color to the vertex to achieve this with the shader. So right now, this is just like the pretty much all my calculations are zeroed out, and what you're seeing right now is just the basic height map. So barycentric functions work just fine on it. But if we go into the actual scene demo, what I'm doing is just grabbing the terrain, and then I have this this class called procedural mesh, which is what I was using to create that procedural sphere that I showed you in a video a couple weeks ago. So I'm just going to be calling proc sphere. It was originally a sphere, that's why the variable is named sphere. Procedural mesh, and then we're going to do test distortion terrain. So we're just taking in the terrain object that's already been set, and then here are our actual parameters. So let's do something a little bit more fun than these zeroed out values. So our distortion value, or rather more accurately the frequency of the distortion, it's going to be set up to 10. Our min value is 0, our max value is 4.3. Alright, so already this is looking quite different, still a little bit chunky. Yeah, so the colors kind of take over, and you can actually see the white now because the I allowed the Y position to get up that high. Yeah, so go too low, it's blue, go too high, it's white. So this is the same height map that we saw before, but there are a little bit more bumps, and that's all based on the actual frequency value. So you can go and bump it up a lot just to see exactly what it does. Whoops. So this should sort of give us like more hills, more ridges. Yeah, so yeah, a little bit more hills there. I don't know if I even want to drive over this. Oh geez, yeah, that's kind of awful. Well, barycentric is working just fine. Yeah. So I'm actually surprised that the tank is able to do that. Yeah, I was sort of messing with updating this at real time, and I was trying to use that linear interpolation function to sort of grab all of the verts, swap in a new model, and obviously that's very costly, and I haven't really figured out a way to do it that's like not completely inefficient. But I did figure out how to do something that just looks kind of cool. So if I tap 2, what's going to happen is I'm going to linearly interpolate between a min-max height value, and the terrain is sort of going to snap up and down based on that lerp value. So let's get, yeah, the skybox is going to start clipping out, so it's just getting closer there. Alright, tap 2. Alright, ooh, that's interesting. I don't want to let this go for too long because you can actually see the memory like spike because it's very, very inefficient. But yeah, so in tank, what I'm actually doing to prevent doing that every frame, I'm actually using an alarm to do that, because I know it's very, very inefficient, and it's probably not being cleaned up correctly either. But that wasn't really part of my initial like implementation. That's not what I wanted to get done. Actually, I didn't achieve at all what I wanted to get done. I wanted spherical terrain. But yeah, I thought that looked kind of cool. Let me find that. Okay. Yeah, so what I'm doing is just interpolating between two float values here, and then passing that in for the distortion. And I'm pretty sure the reason that this doesn't really work the way that I want it to, where it's like all wavy, is that I'm updating the actual position every time instead of taking the original position and interpolating from there. But anyway, let's go into how I actually manage all this stuff and create it. Should be in game objects. Jesus, I forgot where I put it. Here we go. Procedural mesh. So I have a mesh generator class, which I'm using to get data from the terrain and from the sphere, since I initially wanted a spherical terrain, but that just wasn't in the cards for this particular assignment. So I've got a create function and a get data function for a unit sphere. I've also implemented this for the skybox. So this is essentially just the class that we had in the graphics class. That's sort of controlling the creation of models. So get data passes in vertices and an index list, and I'm just setting all of that data to that. So this is really useful when I want to just grab those verts and then do a calculation on them, which I'll show you right here. Okay. So test a source and terrain. Actually, all it does is it's getting the model data from a terrain model that I pass in. So this is the function that I call from the scene level. So we're just passing in a model, getting that data, and then we are calculating a very terrible noise function on it, which is actually originally meant for a sphere. Yeah, so this is the actual function here, and then I'm actually taking each y value here and checking its height and using those great colors that I got. So these are the RGB values here. So change this to something more interesting. Well, I'm feeling a red. There you go. So we know that we've changed something when we come back and look at it. Yeah, so all this has going for it is the procedural model and a mesh graphics object. So, I don't know, it's pretty straightforward. All I'm doing is just calculating things basically the same way that I'm doing it in terrain. So the reason that I have all of those extra functions in terrain is because it wasn't really prudent to offload all of that calculation to procedural mesh and sort of duplicate it, in my opinion. So if we go into terrain.cpp, there's actually a lot of helper functions in here that I use for the calculation. Pretty much once I realized that spherical terrain was going to be a little bit too much for the last week of implementation here. So the main function that really drives all of this is recalculate normals. Because actually so when we initialize the terrain, I don't think I'm calculating the normals the first time. I have another function to initialize without calculating normals, but that's kind of hard to do without first calculating the normals if you don't want a procedural terrain. So I don't think I'm ever calling it. But the important part is, whenever I'm sort of touching the verts here, I need to recalculate the normals so the barycentric like collision can work, and sort of collision with the terrain at all can work. So if you see, I'm actually going to update this model in real time. Oh geez, that looks ugly. Let's just take a look at the God cam here. And I'm going to park the player here. Just kind of awkwardly on the side of this little mountain here. So the normals were recalculated when I was actually calculating the noise function here. I'm going to hit 2 again, and the terrain is going to go flat. And as you can see, I can still move the car around. I can still move my tank around. It's very laggy right now, but I can still move it around as it's doing that. So all I'm doing is just swapping in the mesh. So if I can figure out a way to make that a little bit more efficient, where it doesn't lag, that would be a really cool effect. It doesn't lag on very, very small terrains, but there's no real fun in that. Also, if I can get it to a point where I'm pretty much just manipulating each cell rather than the entire terrain, that would be a lot better. But I do have to swap in and out the entire terrain every single time, even if I just want to manipulate one cell. So this is a relatively small terrain. It's not like an entire world, so it still looks relatively okay if I want to update that in real time. In terms of what I wanted to implement, I could not really resolve the terrain iterator and the cells with a sphere. What I initially wanted to do was essentially just cheat and get like a flat sphere and calculate the normals just by getting the center position of the sphere and just projecting that out based on the position of the vert, because that would give me uniform normals if it's a uniform sphere, and I can create like a pretty cool little demo. But I didn't really think there was much value in that if I couldn't use collision or the iterator or anything. So I think what I ended up with is slightly better than that option, because I can actually update this at real time, although it's very inefficient. And the normals and everything sort of act like they're actually updating in real time rather than just swapping in the model. So I'm not getting any errors with recalculating normals and whatnot. Yeah. Obviously the personal project has been on the back burner for like this entire quarter. So I wish I could have gotten more done in terms of like spherical terrain, because it would have been fun at least to have a tool to calculate normals on sort of like an arbitrary model rather than terrain, because essentially what we're doing with terrain is just it essentially boils down to a 2D calculation rather than a 3D calculation. And I feel like in most instances, especially like when I get into the field, it's gonna be more impressive if I know how to calculate normals on like any 3D mesh. And that would have been a more useful project to have than what I have now, certainly. But yeah, getting this done in like the 11th hour, it was pretty fun. The procedural mesh component was, I think it turned out pretty interesting, especially getting the color to change based on the height. That was something I didn't really expect to get finished, but that worked out just fine. Oh yeah, I also spent a few hours today trying to get diamond squared to work. You probably realize that the function that I'm using, the math that I'm using to actually randomize the terrain is pretty bad. I called it bad noise. It's this really basic noise function that was intended to be used with the sphere, and I just sort of co-opted it with the terrain, took the Y value and slapped it in. So I attempted diamond square, but I didn't get 100% of the way there. I have a bunch of these calculations And if I actually call it, all it does is sort of make the terrain bumpy, which is the exact opposite of what I want. So I can actually call it now, and we can see what it does. But yeah, if I had a better understanding of exactly what Diamond Squared did, it's kind of hard to tell with this high resolution and all the other stuff that I did to it, but it just, I mean, right here you can kind of tell it just makes the terrain slightly more bumpy, which is atrocious with the already bumpy terrain and barycentric coordinates. And this is just, that's just awful. But yeah. So that's all my Diamond Square implementation does, pretty much. Let's see. All right. That pretty much does it for the procedural terrain. The only other thing to talk about is the font system. So I'm sure you noticed the font floating around in the corner. Just have one last demonstration of that. Should probably not do it on this terrain because it's awful. Swap over to this terrain. Okay. So you can see the position of the frigate is updating in real time. Obviously I can print pretty much anything to the screen. You can see that this is updating in real time. I don't really know if there's another case in which I can prove that this is doing something interesting, because this is pretty much the only case that you need to see. I mean, it's updating the position when I move the tank. So yeah, let's just quickly look at the implementation and then we can call it a day. So you've got a sprite font manager, which essentially just takes the TGA and XML and manages them. Where did I put my sprite fonts? Sorry, it's gonna take a hot second. Alright, so I've got my screen log here. Just take a look at sprite font. Come on. There we go. Great. Okay, so sprite font. Yeah, this is essentially exactly what you had in the slides. So I've got a font map that is holding a bunch of glyphs, or sprites, rather. And then we're using that in sprite string, if I can find the freaking thing. Sorry about this. Here we go, sprites, sprite string, there we go. Alright. So what I'm doing in sprite string is taking in a sprite font, obviously, a string that I want to print, and an X and a Y value that's going to act as our position. So I have an offset that's based on the image, the rectangle image on the sprite. It's based on that width. So a lot of people were suggesting just like take an arbitrary character that's sort of like standard, like a 0, and use that as your default width. So that sounded like a pretty good idea. Yeah, so I'm just going through my glyphs and then rendering them. Yeah, fairly straightforward here. So the cool thing is the screen log. So obviously I have that set up as a singleton. This is the add message function that you informed us of through the slides, and then I have this update function. So I'm going to be grabbing a sprite font that I initialize in my main game engine file. So let me go find that real quick just to prove to you that this is indeed utilizing a manager. So we've got the sprite font manager loading up this font. This doesn't actually say XML and TGA. So this sort of relies on the user making sure that the XML and TGA line up perfectly. So yeah, it's sort of like an implementation thing. I didn't put XML or TGA on this. It's just I have a key and then I have the file name for both the XML and TGA. That's how I chose to implement it. But yeah, hopefully with every font implementation that people have, the XML and TGA are going to be named the same. I don't see why they wouldn't. So screen log. Yeah, so all we're doing is just setting up a bunch of fairly arbitrary offsets because we are dealing with these fonts here. The only like solid offset that I do have is when we're looking at sprite string, we're going to be getting this specific glyph and then setting that as a width. But everything else is sort of just eyeballing it, honestly. Yeah. Okay, that pretty much does it for sprite font. It's a relatively straightforward implementation here, and if you need more information about it, obviously, you can take a look at my code. Okay, I think that does it. I'm very tired. Thank you for a wonderful quarter. I'd be very amazed if I didn't have to come back and redo this. Yeah, good luck grading the rest of the assignments. Have a good day.